Welcome to this explainer. Today, we're taking a journey that starts with the deeply grounded science of astrophysics and launches straight into the mind-bending, almost unbelievable theories of higher dimensions. We're looking at one of the most terrifying yet completely awe-inspiring phenomena in the entire cosmos: black holes. Are they simply the universe's ultimate trash compactors, crushing everything into nothingness? Or could they be something much, much more profound? Let's kick things off with a pretty powerful question, one that challenges literally everything we thought we knew about the universe. What if every black hole is more than a cosmic graveyard? What if it is a doorway to another universe? Now, I know that sounds like pure science fiction, but as you'll see, some of the most brilliant physicists alive today are using rigorous math to ask exactly this. Section 1. The Cosmic Graveyard. Before we dive into the wild theories, we have to ground ourselves in what scientists actually know based on observation. And honestly, the sheer scale of the violence required to make one of these objects is just staggering. You see, one type of black hole is born when a massive star completely runs out of nuclear fuel. It can't support its own immense weight anymore, so it collapses inward, explodes outward in a massive supernova, and the core just keeps crushing down. What you're left with is a concentration of matter packed into a space so incredibly tiny and so unbelievably dense that it literally warps the fabric of space-time around it. And all that space-time warping leads us to a crucial boundary known as the event horizon. Now, this isn't a physical surface like the crust of the Earth, it's a mathematical boundary. If you pass the event horizon, well, you've officially crossed the point of no return. Gravity becomes so intense here that absolutely nothing, not even light, which is the fastest thing in the universe, can achieve the escape velocity needed to break free. You are completely, inescapably trapped by the black hole's gravitational grip. Section 2. Beyond the event horizon. So, what actually happens if you take that plunge? As we cross that threshold, we descend into a realm where the strange physics of the interior take over, and reality basically unravels. Inside the event horizon, things get weird fast. First, you'd experience severe time dilation. To someone watching from the outside, your descent would appear to slow down and just freeze, but for you, time marches right on. Next, you'd encounter monstrous tidal forces. And ultimately, according to classical physics, you would hit the singularity, a point of infinite density where our current understanding of physics simply shatters. But before you even reach that singularity, you'd have to deal with a highly scientific yet playfully named concept: spaghettification. Because gravity gets stronger the closer you get to the center, the pull on your feet would be vastly stronger than the pull on your head. So you would be crushed horizontally and stretched vertically, getting infinitely long and thin. You'd literally resemble a piece of spaghetti long before you ever reach the core. Section 3. Gateways to Other Dimensions. Okay, I know that sounds like a pretty grim end, but what if we drop the assumption that there is an infinitely dense, destructive singularity sitting at the center? Physicists have actually been playing around with this idea for years. General relativity predicts total destruction at the singularity, sure, but that creates a massive headache for quantum mechanics, which insists that information can never, ever be totally destroyed. So, enter the dimensional portal hypothesis. This suggests that instead of a singularity, the center of a black hole might house a finite-sized wormhole. It could act like a portal, preserving information and transporting it to a higher dimensional space instead of just erasing it. One fascinating hypothesis, drawing from advanced frameworks like string theory and M-theory, suggests that the extreme gravitational environment inside that event horizon actually triggers a dimensional shift. It allows information to survive by transitioning into extra spatial dimensions that we just can't directly observe. In this view, a black hole isn't a dead end at all, it's an intersection. Section 4. The ER equals EPR theory. This brings us to a bleeding-edge theoretical concept that attempts to visualize the math behind these cosmic gateways. We are diving into a realm where gravity and quantum mechanics finally shake hands, and it's captured in a deceptively simple equation: ER equals EPR. Coined by theoretical physicists Leonard Susskind and Juan Maldacena, this little equation bridges two massive ideas. ER stands for Einstein-Rosen bridges, which is just the scientific term for wormholes, and EPR stands for Einstein, Podolsky, and Rosen, referring to the quantum entanglement of particles. Susskind and Maldacena are proposing something wild here, that wormholes and quantum entanglement are actually the exact same thing, just viewed from different perspectives. To visualize the math behind these cosmic gateways, scientists use what are called Penrose diagrams. The ER equals EPR theory suggests that if you take two black holes and entangle their quantum microstates, they become physically connected by a space-like passage, an Einstein-Rosen bridge, right through the fabric of spacetime. The math basically maps out a geometry where these two incredibly massive objects are essentially two mouths of the exact same throat. Section 5. The biggest scientific challenges. Now, as beautifully elegant as this idea is, we've got to take a step back and do a massive reality check. These ideas are firmly in the realm of theory. Even if these wormholes do exist inside black holes, traversing them is a completely different story. The math indicates that these bridges are incredibly hostile and highly unstable. They are theorized to be plagued by immense radiation and would very likely collapse into a singularity long before any physical object or even a tiny signal could successfully pass through them. Scientists speculate there are three massive hurdles here. First off, calculations show that without a continuous supply of theoretical exotic matter, stuff with negative energy to prop the tunnel open, the wormhole mouths would pinch off and collapse almost instantly. Second, highly blue-shifted light rays would accumulate inside, creating this destructive wall of energy called a blue sheet that would incinerate anything trying to pass. And third, theoretically, traversing these paths requires faster than light travel. Oh, and of course, there's the fact that we simply lack any direct observational proof that any of this exists. Section 6. The ultimate cosmic mystery. So, where does this leave us as we look up at the night sky? Well, we're kind of caught in the middle. We have math that suggests beautiful interconnected universes, and physics that says, nope, the door is slammed shut. We are really standing on the shoulders of giants here. From Albert Einstein and Nathan Rosen's initial math back in 1935, to Stephen Hawking's groundbreaking work on radiation and the information paradox, all the way to modern string theorists. Generations of brilliant minds have struggled with this. Do black holes destroy information forever, completely violating quantum mechanics? Or do they transport it somewhere else, rewriting our entire understanding of spacetime? We simply don't yet know. Which brings us to our final thought. Black holes may be nothing more than cosmic traps, or they may be doorways to realities beyond our imagination. Until science finds the answer, they remain one of the universe's greatest mysteries. Could it be possible that the darkest, most terrifying corners of our universe are actually the keys to another, just waiting for us to unravel their secrets? It's a pretty staggering thought to leave you with. Thanks so much for joining me on this explainer, and keep your eyes on the stars.